Welcome to the Stormsurf video surf forecast for the week starting Wednesday, January 4th. Looking at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. A little bit of a cutoff low is generating 18, 19-foot seas north of Hawaii, aimed somewhat at the islands, generating swell for that area. And also a broader low is set up off the Kuril Islands, generating 20-foot seas, but all aimed back at Kamchatka, with no fetch aimed at our forecast area, being the Hawaii, U.S. West Coast up into Canada and down into Mexico area. Let's get into the details. We'll start off our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. We're looking for a trough. That is a dip in the jet stream, just like this, going to the south. That helps support counterclockwise flow aloft and also down at the surface, and that is the hallmark of low pressure. Okay, and of course low pressure generates wind, wind generates seas, seas generate swell, which makes surf when it hits your beach. All right, so we have a pretty decent flow flowing up, pushing off Japan. Winds, what is that, about 140, 150 knots. But the issue is, as it has been for the past several weeks now, a split in the jet stream located just west of the dateline, pushing a good amount of energy up into the Bering Sea, and it was even further north than this, almost up into the Arctic Circle, pushing into Alaska, and then falling down interior to the U.S. coast. We have a bit of a cutoff low here. That is theoretically generating a little bit of wind activity, but not really a main weather producer. When you get these split patterns like this, in between the two split streams, typically you get high pressure. So that is not conducive to storm and swell formation. But also notice it is pushing directly into the California coast, and that is making for a rather healthy weather pattern across California, and certainly snow producer for the Sierras. Anyway, so let's move through this, see what's going on. As we move 30 hours, 36 hours, pretty much the same thing going on. If anything, the jet gets more pronounced, the split is more pronounced, but notice a little bit of a backdoor trough here. That is a trough that is over land and sort of peaks out and then moves back in, is to develop off the Canadian coast on Friday and start falling south. A little bit of fetch might be associated with that. That might also bring a little bit cooler air in the areas along the coast where it is present. Notice the jet continuing to push into California into Sunday, still producing weather, still the split pattern at 96 hours out. We'll just keep going. Now notice when we get out to about Tuesday or so, the split becomes a little bit less pronounced, more energy pushing across the Pacific, flat on about 35 north latitude line. Bit of a trough also trying to dig out here north of Hawaii, in addition to the semi-permanent trough off the Kuril Islands. We'll go just a little bit further and see how that plays out now. See, at 168 hours, we start to see again the emergence of the split. Same sort of pattern going on at 180 hours. So we're into Wednesday night a week from now. Not super conducive to storm development. The thought is this is all attributable to La Nina and the inactive, well, not even the inactive phase of the MJO. We'll get into the details, but the MJO is basically weak. La Nina's in control. That's not feeding the jet, not giving it enough energy to continue to push this way across the Pacific. Also note that the bulk or the bolus of the cold water associated with what is our minimal weak La Nina is generally right in this area, which is right about where the split is, and which would also assume generally a high pressure ridge right north of it, pushing the jet up and over, and effectively that's what we have. Weather pattern here in the Eastern Gulf, weather pattern in the West Pacific, and not a whole lot in between. Let's go take a look down at the surface. So here we are, surface level pressure, surface level winds, pretty much as expected, cutoff low. Remember, the jet's going up here, so this low off of California is not being fed by the jet directly at all. Therefore, it remains relatively weak. 30-knot winds in the northern quadrant, and a little bit wrapping around in the northwestern quadrant, probably setting up some wind swell for the northeastern shores of Hawaii, but certainly nothing aimed at the U.S. West Coast. And then here's our broader gale, which actually pushed off Japan 2 days ago and is now starting. Remember how that trough is set up right like this? It's helping to feed it, but also drawing it off to the north. No real fetch aimed anywhere except at Kamchatka and the northern Kurils. Let's put this into motion, see how it plays out. So our cutoff low remains here. A secondary low starts forming in the West Pacific on Thursday. Not really much wind associated with little patches of 30-knot winds. And the previous fetch from the low moves inland over Kamchatka. Now this low has been progged to develop and still is to do that. Also notice low pressure, that backdoor trough we saw in the Gulf, generating 30-knot north winds. Now here's 30, 35-knot, 40-knot winds on the dateline, all aimed to the north. It's just this little fetch here of 30, 35-knot winds, sort of aimed at Hawaii and the U.S. West Coast. That builds a little bit finally into Saturday night. We get some 45-knot winds aimed mainly to the east, a little bit to the southeast, so perhaps some swell could be generated affecting this whole area in here. Roll that out. Fetch continues into Sunday night. Now another low pushes off Japan, and this one currently is forecast to get pretty solid. This is not a low anymore or a gale. It is a storm with projected 55-knot winds. Of course, it's not a storm until it actually happens. But at this point in time, 55-knot winds into Monday night, fading. Oh, still 55-knot. You can just see a corner of that fetch off the labels here. Probably about a 964 millibar low. Moving towards the dateline, 50-knot winds. Looks pretty good, but that's a long way from being reality. But if it does form, that is at least a step in the right direction. Let's go take a look at the wave models. So here we go, our 18-foot seas again, as we talked about earlier, and a little patch of 20-foot seas, but all aimed at Kamchatka. Let's put this into motion. We see not a whole lot going on till we get into Friday. Remember, there's a gale trying to form in this area. Also, low pressure in the Gulf of Alaska falling south. We get, 23-foot seas pushing south, probably targeting more Hawaii than the U.S. West Coast on Saturday. And roll this out some more. More 20, 21-foot seas, again, aimed well at Hawaii, and from a rather obtuse angle. It's north-northeast almost, and that's a good kind of obtuse for certain breaks in the Hawaiian Islands. Fetch and seas developing almost 30 feet on Sunday off Kamchatka, aimed, not a large fetch area, but enough to probably produce some little swell. Roll this out. The low in the Gulf continues to be not particularly impressive. And then a new system pushing off Japan on Monday night. 34-foot seas building into the 44-foot range and 45 feet. That looks pretty impressive. Still, it's on the other side of the dateline. Good amount of energy, theoretically, if it were to develop, aimed at Hawaii and the U.S. West Coast, but from a long ways away. We'll see how this really plays out, and then it starts moving off to the north and fading out. But still, a good amount of secondary fetch, certainly a long run of swell for Hawaii, and lesser energy for the U.S. West Coast if it were to materialize. We tend to not believe any of the models more than about 4 days out after that. It gives you sort of an idea of what might happen, but certainly you would not want to bet the bank on anything that far into the future. Also, a quick look at the southern hemi. Believe it or not, a gale developed south of New Zealand. Winds almost 50 knots, so that'd be almost a small storm. Seas 39 feet. This was on Tuesday night a week ago, and it quickly kind of faded out and fell south. But small swell is hitting Hawaii from this. So this is January 1st, a southern hemi storm with swell hitting Hawaii. The buoy was showing, I think it was 2.5 feet at 15.9 seconds. That's pure swell. Good for maybe 4-foot surf on the south shore this morning, but that should be fading off rather quick by tomorrow. Still, kind of interesting to see that this time of year. And we would be remiss if we did not discuss precipitation in California, mainly because it has been so long since we've had real precipitation of any magnitude and with any duration. This year, though, actually has started out pretty good and continues. So the white boundary around this, if you look at the scale here, and we'll show you, this is the snow boundary. This is the snow gauge scale and the rain gauge, the only difference between the two is there's white here in the snow. Otherwise, they look remarkably similar. So if you look in the higher elevations and you see a thin boundary of white, or if not gray, if you look real close, then that means snow versus rain. So here we go. We'll sort of, let's see if we can center this and roll this out. Here we go. Okay, so Sierra on Wednesday, snow. Tapering off on Thursday, but still snowing, and mainly looking at Tahoe down here into the Mammoth area. Still snow. Friday, things clear up for just a brief minute until Saturday. The next batch arrives, snow in the higher elevations continuing. Now here's where things get kind of interesting, but not in a good way. All that snow turns to rain in the Sierra, except in the highest elevations of the southern Sierra, and then it just starts pouring rain. You can see that little white stripe down the middle. That's snow. All the rest of this is heavy amounts of rain in the Sierra and mainly the southern Sierra, and it just bombs rain. Oops. You can see again right there. This is on Sunday 18Z, so about 10 a.m. Little bits of snow at the highest elevations. And then finally, as you get into Monday, then it changes over to snow. But the storm sort of peters out. But the interesting thing is, here we go. The next one queues up Tuesday night, theoretically, and it, too, starts bombing. This is snow, as best we can tell right now, into 168 hours out and continuing into Wednesday night. So yet more to come. I believe Squall reported 4 feet as of this morning, and they got another almost foot as of today. Temperatures were a little on the warm side, 32 degrees, even up at 8,000 feet. And it was 33, 34 down in the parking lot there. A little bit cooler at Kirkwood. Still, good amounts of snow. This is exactly what we need. And then we also have our snow model. We'll actually step this back. So the 0 hour has nothing on it, but you can see Lake Tahoe. You can see 80 going up to the North Lake, 50 heading to South Lake. We have the major ski resorts and major towns along some of the routes indicated. Also notice here, accumulated snow. So at some of these, like Sugar Bowl, Squaw Valley, Kirkwood, we actually picked out the coordinates of the peak of the highest chair on the mountain, centered it on that, and then start accumulating snowfall amounts at those locations. So 7 a.m. Wednesday, and we'll just roll this through. Also notice here, this is the peak snow amount for that 3-hour period. So you can see 6 inches down here, even south of Heavenly, another 6+ inches, and that's in a 3-hour period. You kind of get and then here are the accumulations. The numbers might be a little bit off. I think they're probably biased a little bit on the high side. And as we get into Thursday evening, they're talking another, I'll say 3 to 4 feet, maybe a little bit on the high side, but certainly multiple feet is expected. Then things dry out. And then we go into Friday, and then Saturday, here comes the next wave. And you can also get a hint of the elevation where the rain turns to snow, just outside of Applegate, probably around the Colfax area on Saturday morning. And then you can see as we get into this, into 84 hours out Saturday afternoon, the snow level gets higher and higher. So anyway, you can use this different model. It only goes out 84 hours, but to get a high-res view of what's going on snow-wise, you can use it to plan trips up there and try to avoid the worst of the snow and the backups on the highways. Make your stealth trip, get in there before the storm hits. All right, long-term outlook. What's going on with the Madden-Julian Oscillation and La Nina? So first off, we start looking for signs of what the Madden-Julian Oscillation is doing. The MJO is a pattern that exists over the Pacific in 3 to 4 week cycles, 3 weeks on, 3 weeks off. When it's on in the active phase, it tends to suppress trades or apps, or can in fact reverse them if the active phase is strong enough. This in turn feeds the jet stream and helps produce produce more and stronger storms and therefore more surf. And then when it goes in the inactive phase, trades are enhanced. The jet stream gets starved of energy, and you get the split pattern like what we're seeing right now. Longer term, La Nina tends to be like a long-running inactive phase of the MJO, and when the active phase does come in La Nina, it tends to tamp it down a little bit. And likewise, in El Nino, when you have the active phase, it enhances it, and the inactive phase of the MJO sort of stomps it down a little bit. Right now, we see trades in effect. This per the TAO buoy array. Buoys strung across the equator, pretty much 5 degrees north and south in increments. So this is good data. This is a 5-day mean and average, so it's not absolute winds at this moment in time. Easterly winds in control until you get to what we call the Kelvin wave generation area, which runs from about 170 west to 135 east. Build a box right along here, 5 degrees north or south of the equator. That's where we look for the presence of the MJO and or El Nino and La Nina. And we see that we have strong easterly winds, but much weaker here in the western Kelvin wave generation area. Anomalies, differences in normal for this time of year. Actually, even though La Nina is in effect, it's pretty strong. Winds are basically normal, maybe slight easterly. But notice this, in the western Kelvin wave generation area, winds are normal, if not tending slightly from the west. Nothing too remarkable, but a little bit of hope. Looking at wind anomalies, so here we go. South America, Mexico, Australia, Philippines, Kelvin wave generation area, that same little box just right along in here. We see kind of a mixed pattern, a little bit of west, a little bit of east, and just going day by day. Don't see anything too much. See a little bit of easterly anomalies on January 1st in the far western Kelvin wave generation area, but generally kind of a muddled pattern. Nothing too remarkable, not clearly indicative of either the active or the inactive phase of the MJO. So this is a look past and at the future. This is the whole planet on one chart. Kelvin wave generation areas between these two tick marks. Date line here. This is about, what is that, 140 or 130 or, no, 120 east, I'm sorry. So you can go down and look in this area, and you see this pattern even back in December. Westerly anomalies in the far western Kelvin wave generation area. Easterly anomalies right on the date line. Here's a pulse of the inactive phase of the MJO around Christmas time. And now here is where we are right now. Again, westerly anomalies trying to make some inroads. There's just like this brick wall right here, and it's pretty much been here the whole way through as you look at this. And strong, so right now, there's this dividing line between westerly anomalies almost on the date line and easterly anomalies east of there. And you see as we go for the next week, January 4th through about the 11th, pretty much the same thing, only easterly anomalies building, but then westerly anomalies building too, out to, what is that, about 150 east. So no clear signs yet of anything in terms of the MJO. Now notice this pattern here. This is all in the Indian Ocean here. We want to see this starting to move this way, and we want to see these easterly anomalies starting to move more this way. That would suggest to us that the La Nina in the atmosphere is starting to die and fade out. So we continue on our hunt looking for evidence of what the MJO is doing. This is outgoing long wave radiation. So these areas in blue show less sunlight reflectivity off the ocean's surface, indicating cloud cover, indicating the active phase of the MJO. More sunlight reflectivity, positive numbers on the scale, suggesting high pressure in the inactive phase of the MJO. And this is the statistical model. And it suggests basically a weak inactive phase of the MJO is over the Kelvin wave generation area, which again, you can draw a little box right around here. And that it's supposed to fade out and go completely neutral 2 weeks from now. The GEFS model, the GFS ensemble model, suggests basically the same thing, but with the active phase of the MJO trying to make some inroads into the West Pacific, but then dissipating. Next up, phase diagram charts. So again, assume you're looking down on the North Pole of our planet. The MJO travels from west to east this way, counterclockwise around the chart, from the Indian Ocean to the maritime continent, think Bali. across the dateline West Pacific, under the U.S. West Coast, into the Atlantic, over top of Africa, and back to the Indian Ocean. The big dot, like right there, that suggests where the active phase of the MJO is. If it's within this circle, it's considered to be extremely weak. And so the active phase is supposedly, per this model, the ECMF model, in the Indian Ocean. Notice the different strings, different runs of the model under different conditions suggested is to, at some point, maybe about a week out, start making inroads into the West Pacific. Strength is generally right on the hairy edge of this circle, meaning pretty weak. The GEFS model suggests not even that much. It's maybe to make a little blip here out to the dateline and then collapse into the internal of the circle. There is yet another model we use sometimes. This is up in jet stream level. Green suggests precipitation, odds for precipitation, so one could say it's the active phase of the MJO. Runs about 2 weeks ahead of schedule, so if it's showing here off of New Guinea, it's probably the core of the MJO is probably here in the Indian Ocean somewhere. But anyway, it suggests some sort of a weak active pattern. This thing goes out 40 days. Weak active pattern making it to the dateline out in late January and dissipating, followed by a inactive phase of the MJO that does the same thing, goes out and dies, followed by yet another active phase of the MJO, trying to make some progress to the west out in mid-February. And then finally, the predictions from the CFS model. 850 millibar winds. He's up about 4,500 feet. Good approximation of what's going on down at the surface. Again, same sort of chart. Whole world on one chart. Dateline runs right up the middle. The Kelvin wave generation area is roughly right in that area, running the whole way up the chart. And you can see the same pattern. Westerly anomalies, the yellows and oranges are westerly anomalies in the Indian Ocean. Here's where we are current. The forecast is up here. And currently we're seeing, and same sort of thing, strong easterly anomalies building right on the dateline a little bit east of there in the next week, with pretty solid westerly anomalies barely making it into the West Pacific Ocean. Now let's overlay the MJO, and you can see the solid contours are the active phase of the MJO continuing. So it's just now starting to get going. At some point it's supposed to kind of stomp on these easterly anomalies, put a dent in them, but no real westerly anomalies are forecast to develop. This rolls out into, well, almost the end of February before it dissipates. The inactive phase of the MJO starts in the West Pacific in late February and continues on into April. So this window somewhere right in here is probably our best shot for surf. Let's say mid-January into about mid-February or so. And then after that, the inactive phase takes over. The jet stream will split again, and then we'll probably be in a pattern similar to where we are right now per this model. So atmospherically, the MJO is in play, but what's really happening is La Nina is the dominant. It's the longer wave cycle that's going on, and the MJO just sort of modulates it. We're trying to get into the active phase. It'll dampen La Nina a little bit, but again, bear in mind, this La Nina is extremely weak. So what you have is a convergence of extremely weak patterns, both the La Nina and the MJO, and neither one is manifesting itself strongly. So it becomes very difficult to tease out what's going on atmospherically and to tease out any sort of a forecast. But what we have seen is the MJO is just not strongly influencing the atmosphere. So even if it does turn active, there's, it's unsure whether there will be a significant positive impact or not. Anyway, so let's take a look down in the ocean. Temperatures at depth, West Pacific here, East Pacific here, down 200 meters, 400 meters. What we see is absolute temperature in Celsius. The 28-degree isotherm pretty much stops right here on the dateline. All the warm water is pulled up in a pocket here in the West Pacific, pretty typical of La Nina, and then the water gets progressively cooler and less, the depth of the warm water shallower as you move to the East Pacific. When you're in when you're in El Nino, this warm water gets pushed off to the east. This is pretty much Yeah, it's cooler than normal, but not a whole lot. In fact, here we go. Anomalies, differences in normal for this time of year. And what you see is that warm water is making a little bit of inroads. Where is that? Oh, maybe south of Hawaii or so. And what's most interesting about this picture is this area of cooler water, and we're talking pretty much not even barely 1 degree below normal, is getting progressively shallower and progressively warmer, suggesting that La Nina is fading out. I mean, this is barely a La Nina situation compared to what we were seeing, where there was 3 and 4 degree below normal pockets, and a large one covering this whole area in here 4 months ago. This has moderated significantly, and that is a good sign. The more conservative view of the subsurface profile, same deal. West Pacific here, East Pacific here, depth. These blues, which are 2 shades in, so about 1 degree, almost 2 degrees below normal, are breaking up. Way less coverage than before. Warm water making much more coverage to the east. We're not saying this is a Kelvin wave or anything like that, because it's not organized. There's no real westerly anomalies, but just sort of a mixing, suggesting that the cool water in the East Pacific, which is the hallmark of La Nina, is dissipating. And our favorite chart here, upper ocean heat anomalies, upper 300 meters of the ocean. You can see this was the last Kelvin wave, warm water push from El Nino back a year ago in February. Kelvin wave number 6, fading out. The onset of La Nina in the springtime of 2016. Cool water comes rushing to the east. It sort of broke up a little bit, got a second pulse in November, but look at it now. You can just see the water, cooler waters retreating, warmer water definitely making eastward progress. Now, this is not to suggest that anything like El Nino or anything, but just a steady march towards normal. If this is the sum total of our La Nina, that's a good thing. We'll take it. It's a very short-lived and weak La Nina at that. Sea level anomaly data also suggesting much the same. This is the Jason 2 satellites. Strip out all the wind, strip out wind-driven waves, swell, tides, any other anomalies, and just absolute height of the ocean surface where it's a little bit depressed, 5 centimeters. That suggests cooler water at depth. Cooler water, of course, contracts a little bit, making a little bit of an indentation in the surface. Warmer water at depth expands, pushes the surface up. A little bit of an anomaly here, but the coverage of the negative anomalies is every update of this, and it updates, I think, every 5 days, steadily is getting smaller and smaller, suggesting La Nina is dying. Then we look at sea surface, not subsurface, surface temperature data, anomalies, differences from normal this time of year. We see a small pocket, thin little stream here, as is normal, along Peru of cooler waters. The blues are cooler, and here's the scale right here. Warmer is the reds, but you also see it completely encased in warmer than normal water. There was this cool pool that was off between the Galapagos and Ecuador and Costa Rica. That has all dissipated. Warmer water building there up into Mexico. Here is the La Nina cool pool. It starts at the Galapagos and kind of limps off to the east, but doesn't really start building till you get out south of Hawaii. This is pretty typical of how it's been. And here's the trend, 7-day trend as of January 3rd. You can see still warming off of Peru, warming off of Ecuador, and even warming a little bit west of the Galapagos. Then we get into this sort of mixed bag of warm, cool pockets. But even that pattern is dissipating. It was marked and very pronounced in the spring and the summer as La Nina was trying to develop, but now even that is dissipating, and so that is another good sign. And then, of course, the overview picture, you can just sort of see, again, this is anomalies, differences from normal. You see warmer water here along the coast, the thin little cool pool developing at the Galapagos, but the bulk of the cool water is out here south of Hawaii. And so when we talked about this earlier, normally high pressure sets up north of where the cool pool is in La Nina. If this was a warm pool, El Nino, wherever it was, that's where low pressure would set up. And the previous El Nino was sort of a westward displaced El Nino. Most of the warmth was out here. Low pressure was out here. California didn't get the precipitation it expected, and all that sort of makes sense looking in retrospect, even though there was much hype and we expected this major El Nino that was just going to slam into this area, South America. It really didn't do that. It stayed sort of more displaced. Likewise, this La Nina is definitely westward displaced. It has never really made significant inroads into the Galapagos, and the bulk of the cooling has held out here, which is good in some respects. So what we said, the jet stream and high pressure would track to the north and down in, and that's actually allowed California to get a good amount of precipitation, a little bit sporadic in its how it arrives, but when it comes, it certainly comes in buckets, and we're getting that right now. Just one quick little foray. So this is the amplitude of the MJO. We're sort of backtracking here, but these are the peaks of the active phase of the MJO. We're back in 2011. I'm not going to go through all that data, but 2015, these are the big spikes of the active phase of the MJO, and modified, or again, it's the MJO on top of El Nino, and you can see the spikes are off the chart, where in previous years the active phase was much more modest in its impact. And then we got into January 2016, and still pretty active, but you can see the trend was from here, weaker, weaker, weaker. Here's the active phase, pretty weak, and then, so this is December, it was the inactive phase of the MJO, and now you can see it the beginning of 2017. We're just still inactive phase of the MJO according to this chart, and pretty weak at that. So that just supports all the other data we've seen that suggests the MJO is weak and not doing a whole lot to influence the weather pattern. So what impact does the MJO and specifically La Nina have on the atmosphere? We've talked about the ocean. The atmosphere is what drives, of course, the jet stream and winds, and that's what swell production is all about. It's the interaction of water and the air. So let's focus on the air a little bit. We look at the Southern Oscillation Index, difference in pressure between Tahiti and Darwin, to try to tease out what the trend is. Negative values here, prolonged negative values suggest the active phase of the MJO. They suggest low pressure over Tahiti. Positive values suggest the inactive phase of the MJO and higher pressure over Tahiti. Anyway, looking down, here we are. These numbers suggest pretty high pressure over Tahiti, the inactive phase of the MJO, and that sort of seems all depressing. But then you look at the 30-day running average, and yes, it is positive, but not markedly so at all. There is your inactive or your active phase of the MJO. Notice the negative numbers here in the December time frame, and there was actually a pretty good run of surf even into Christmas. Northern California had consistent 8 to 10 foot surf, if not bigger, and good clean conditions right around the Christmas time frame. But that's all over now. We're down to a couple of feet and wind blown and a mess. Anyway, inactive phase of the MJO setting up, it appears. Look at the 90-day trend. The 90-day trend suggests either La Nina or El Nino. This was showing positive, suggesting La Nina, and it was weakening more, and still in the negative. Basically, it's 0, which suggests neither La Nina or El Nino. Here's a 30-day average, Southern Oscillation Index average on a chart. Here was our big El Nino 2015 into 2016, negative numbers. Then the inactive phase of the MJO set up in, about the May time frame, and the trend was steadily upward. Now here is our big push. This was in November of the active phase of the MJO. Now we looked at all the models, we looked at everything. It was very hard to physically prove that that's what it was, but that's the best guess. Is it was kind of masked by all the La Nina stuff, but it pulsed, and now we're starting to get some rebound from that. Just this continual steady upward tick, suggesting the inactive phase of the MJO and La Nina trying to get its grip back on the pattern, but we suspect that will be short-lived. And the last piece of atmospheric data, the ESPI index, instead of measuring differences in pressure in these two areas, north of Darwin and north of Tahiti, it's absolute precipitation satellite measured data. Negative numbers suggest the inactive phase of the MJO, suggesting less precipitation in this box right here. Positive numbers suggest more precipitation in this box. If you have more precipitation here, you have warm water down at the surface, and that's pretty much the hallmark of El Nino. When you have negative numbers, less precipitation, cooler water, remember, right, that we talked about south of Hawaii, that means high pressure and La Nina. The current value, minus 1.20. It's been sitting here for probably 2 weeks, somewhere in that. It was down, I forget when it was, early November, or maybe even before then. It was down to like minus 1.9. It went up, I think, to almost minus 0.8, and then sort of dropped back down to minus 1.2, but hasn't gotten any lower than that in 2 weeks or so, and is slowly inching its way up, suggesting maybe La Nina is fading some. And then finally, the forecast, Nino 3.4 sea surface temperature anomalies, okay? The ultimate determiner of what's going on with El Nino and La Nina. Of course, warmer temperatures in the Nino 3.4 region. This is the area from 120 west to 170 west, or, just a little bit west of the Galapagos out to almost the dateline. Here was our big El Nino, January 2016, fading off, plus almost 3-degree anomalies. Then here was our La Nina setting up in July, only half a degree, pretty much hanging there. And now here we are in January. This actually has an update. This is still a prediction, but it suggests we're almost dead neutral in January, and then rising from there, according to this, to almost minimal El Nino category in April. Don't believe that for a heartbeat. And then just hanging right around in there into the fall. So again, this model suggesting La Nina is effectively over as of right now, and things are only going to get warmer from here. A quick look at actuals mapped over time, and you can see there's minus 1 degree anomalies in the same region that was modeled. Now notice real data is a lot noisier than looking at the forecast model. And you know that from looking at the wave models, looking at the surf. The models say one thing, and what happens in reality is something totally different. But you can definitely see the trend line is going upwards, and probably somewhere, this is probably pretty close to where we are right now at minus 0.297 degrees. I don't know that anyone could notice a quarter or a third of a degree difference in temperature, suggesting there in the main area, the temperatures, now there are pockets of cool, pockets of warm, but temperatures certainly are approaching normal. So to put a bow on things, not much happening in the Pacific right now, swell-wise, weather-wise, onslaught of precipitation hitting California, and much more to follow. The other good news is storm production in the jet stream looks like it's going to wake up a little bit. We might get a brief spurt of swell, most of it long distance from across the dateline relative to California and Hawaii, but any swell is better than no swell, and that's about what we're suffering through right now, so we'll take what we can get. In the meantime, there is snow in the mountains, a little bit dangerous, a little bit avalanche-y. Proceed with caution, but if you can get some of it, go do that. We are going to do the same. We make no promises on when exactly the next video forecast will be. We normally try to do it on Sundays. If we have the time and the energy, we will do it. If not, it'll be a day or two later, but we will not be neglectful, and we'll try to get back to our regularly scheduled timing as soon as the weather and the snow permits. So thanks for watching. We'll do this again, hopefully within the week, and we'll see you next time. Bye.